Hello. So welcome back to this course on the design of cluster randomized trials in cancer care delivery research. So we're going to continue our introduction into cluster randomized trials. And here we're going to start to look at the stepped wedge cluster randomized design. So what we're going to do in this session is first of all introduce some common terminology that's used when describing the stepped wedge design. We're then going on to build on some concepts that we've already introduced, so thinking about cohort and cross-sectional sampling, and when and whether participants are recruited into the study. Then we'll go on to outline some new methodological complexities that this design brings with it. And these include whether or not the intervention delivery can change over the duration of the study, the issue of temporal confounding, longitudinal correlations, and within cluster contamination. Then we'll introduce a few examples that will illustrate some of the different design variations. So to begin with, a bit of history. The first stepped wedge cluster randomized trial was probably a study called the Gambia Hepatitis Intervention Trial. This was a nationwide evaluation of the HBV vaccine in Gambia. The vaccine program was rolled out in a phased but also random way over a period of 4 years from 1986 to 1990. So schematic representation of the study design over here. We've got 17 clusters, which in this setting represent 17 different regions of the Gambia. And then each of the different regions was randomly allocated to the time at which it would transition from the usual care, where usual care is infants who are being born in that region at that particular time, not receiving the HBV vaccine, to transition to the intervention condition. And in the intervention condition in this setting is babies who were born in that region at that particular time are offered the HBV vaccine. So in total, around 60,000 children were born at a time at which their region had not yet transitioned to the intervention condition, and a similar number of babies were born over the period at which their region had transitioned, and so they received or at least offered the vaccine. So the primary outcome is liver cancer, ascertained from a national cancer registry with 30 years follow-up. Study still hasn't reported yet, interestingly, and the reason why the investigators adopted this study design, they say, was because the instantaneous and universal vaccination in the country was impossible for logistic and financial reasons. And throughout this session and the next few sessions, we're going to come back and address whether this justification for the choice of using a stepped wedge design is appropriate and justifiable. So we're going to critically appraise that justification. So we're going to start by looking at a schematic representation of the stepped wedge design. In this schematic representation, we've got 6 clusters. And each of the clusters gradually and also randomly transition from the control to the intervention condition. So the control is the shaded white area here, and the intervention condition is the light shaded blue. And the dark shaded blue represents what we call a transition period, a period in which the intervention is rolled out in each of the clusters. And then the study design is divided up into 7 periods of time, so there's one more period than there are clusters. Now, there's a set of terminology that should be adopted when talking about a stepped wedge design. We talk about clusters being allocated to sequences. So clusters 1 and 2 here have been allocated to sequence 1, 3 and 4 allocated to sequence 2, and so on. And these sequences dictate the order with which the intervention will be received in that particular cluster. So clusters allocated to sequence 1 are observed first of all for a period under the control condition, and then transition to the intervention condition for the next 4 periods in the study, whereas clusters allocated to sequence 2 spend 2 periods under the control condition and then transition to the intervention condition, and so on. And the times at which clusters transition to the intervention condition are referred to as steps. And the time between 2 different steps is referred to as the step length. And then in this design, we can think about not only observations being clustered within clusters, but also within cluster periods. So we might expect observations within the same cluster to be more similar compared to observations from different clusters. But likewise, we might also expect observations from the same cluster period, because they're in a similar time period, to be more highly correlated compared to observations in different cluster periods. We'll think through this a little bit more in what follows. Now, the popularity of the stepped wedge trial is also growing. There are a lot fewer stepped wedge trials published than there are parallel designs and likewise cluster crossover designs, but nonetheless, again, over the past decade or so, the popularity of this particular study design has shown a steady increase. So let's move on and first of all think through some key design aspects. So stepped wedge designs have many different variations. There isn't one size that fits all, and every stepped wedge design will be different to any other stepped wedge design. But there are some key variations in the design that are similar to those same issues that we had to consider when we first thought about multiple period or longitudinal designs. And those are whether repeated measures are taken on participants, i.e., whether the study adopts cohort or cross-sectional sampling, and when and whether participants will be recruited into the study. Now, there are also some other variations in the stepped wedge design that will be introduced for the first time here. And essentially, this is whether the intervention delivery can change over the duration of the study. So the next slides are going to introduce all of these concepts in a bit more detail. So first of all, the issue of repeated measures. So stepped wedge trials, like multiple period cluster crossover designs, can take measurements on different participants at each measurement occasion. So we call this cross-sectional sampling. So at every different period in the design, a different participant is measured. But likewise, the same participants might be measured at each measurement occasion. So the study might adopt a cohort sampling mechanism. So for example, here's one person in cluster 1, and that person is repeatedly measured in each of the different study periods. And then an open cohort is a design where participants are repeatedly measured, but they might not all join the study at the start. So just like in other cluster designs, stepped wedge designs can either take a form where they use cross-sectional sampling or cohort sampling, sometimes a mixture, and sometimes this modification of an open cohort design. And likewise, stepped wedge designs can adopt different approaches as to how they recruit their participants. So participants might be recruited into the trial at the very beginning before randomization of clusters to sequences, or participants might be randomly sampled to participate in outcome assessments, or a complete enumeration of the entire cluster might be taken without any participant recruitment. So we observed these similar types of mechanisms in a conventional cluster trial with a baseline period, and a cluster randomized crossover design. And the same processes happen and occur in stepped wedge trials too. But what differs is how the intervention can be delivered. So we can imagine that in some settings, like on the top left here, we might imagine that our intervention has a single delivery at setup, illustrated by the dark transition cells here. And then after that point in time, the intervention is embedded and nothing else happens. Or it might be the case that we have a repeated delivery of the intervention. So perhaps at each of the different steps, something occurs in that cluster to reinforce that intervention in clusters where the intervention has already been embedded into practice. So we might have a repeated delivery of the intervention. And then if, for example, we have a single delivery of the intervention at setup, then it might be that we might expect a decreasing impact of the intervention. So immediately after it has been put in place in that cluster, we might expect quite a large effect, but then it might be the case that because nothing else happens to the intervention, it's not reinforced, that there may be a decreasing effect or impact of that intervention. But if there's repeated delivery of the intervention, then likewise we might expect an increasing impact of the intervention. So as the intervention becomes reinforced repeatedly over time, then the effect of that will begin to steadily increase. So moving on once again, we're now going to think about some key methodological aspects. So stepped-wedge trials include many methodological complexities that are not usually present in conventional parallel cluster trials. And these include temporal confounding, longitudinal correlations within cluster contamination, and time-varying treatment effects. And so over the next slides, we'll introduce each of these concepts in a bit more detail. So the first and probably most important issue is temporal confounding. So observations collected under the control condition, that's over here in the light shaded cells, occur systematically earlier than those observations that are collected under the intervention condition. These are the shaded blue cells on the right-hand side. Now, observations or outcomes might change over time. We might call this an underlying trend. And this change over time might have nothing to do with the intervention that we're evaluating. Things might just be gradually improving over time or gradually getting worse over time. But because of the relationship between time and exposure to the intervention, this therefore means that time might be partially confounded with the treatment effect. So the stepped wedge design induces a confounder. Remember, with most randomized trial designs, we randomize to eliminate the impact of any confounders. But because of the way the stepped wedge design is set up, because observations under the control condition are systematically earlier in calendar time compared to those under the intervention condition, the design itself induces a potential confounder. There are potential solutions to this. And essentially, we must allow for time effects at the design and the analysis stage. This means we have to carry out what's known as a model-based analysis. And in future sessions, we will look at in a lot of detail how we can allow for these time effects. But that's a first methodological complexity with the stepped wedge design. The second methodological complexity are what are known as longitudinal correlations. So correlation structures are more complex than those that arise in a parallel cluster trial. So we're all familiar with the concept of an intra-cluster correlation, otherwise known as an ICC. Now, when planning and designing a cluster trial, these correlations must be allowed for. And these correlations represent the correlation between two observations within the same cluster. And it's expected that these observations within this cluster will be more highly correlated compared to observations, say, in another cluster down here. We typically refer to this as the intra-cluster correlation coefficient, or ICC for short. Here, we're going to refer to it as the within-cluster ICC. But in a longitudinal study design, we have other correlations that are important to consider. And two of them are illustrated here. The first is what we call the between period ICC, and the second is what we're referring to as the within period ICC. Sometimes we use the acronym WPICC and BPICC for short. Now, the between period ICC represents the correlation between two observations within the same cluster. So these two observations are in the same cluster, but they're in different periods. so between period ICC, whereas the within period ICC represents the correlation between two observations within the same cluster and the same period. Now, it's anticipated that two observations within the same cluster period will be more highly correlated compared to two observations in the same cluster, but in two different periods. Now, these correlations are important both at the design and the analysis stage of stepped wedge trials, and in sessions 4 and session 6, we will look at this in a lot more detail. But this is the second methodological complexity that arises within a stepped wedge trial. So it's no longer sufficient to think about a simple correlation structure, a single ICC, but rather it's important to break down those correlations and allow for the fact that observations within the same cluster period are likely to be more highly correlated compared to observations within different cluster periods. The third methodological complexity is what is known as within cluster contamination. So in parallel cluster trials, the clusters are chosen to avoid contamination. So in a cluster trial, we've often opted to use cluster randomization because of a fear of contamination. And so by choosing our clusters, we have implicitly or explicitly obtained a way of minimizing the risk of contamination. However, in a stepped wedge trial, because each cluster receives both the control and intervention condition, contamination can become a concern again. So the first issue is what we might call contamination with the intervention. So outcomes that are collected under the control condition might become exposed to the intervention condition. So for example, if we take a participant in cluster 3 and we try to observe their outcomes, it might be the case that if we try to observe them too close to when that cluster transitions to the treatment condition, that participant may get exposed to the treatment condition, and so their outcome might become contaminated with the intervention condition. But it can also happen the other way around. We might refer to this as contamination with the control condition. So we might try to elicit an outcome under the treatment condition. So in cluster 1 here, we might try to elicit an outcome during period 2 when that cluster should be exposed to the intervention condition. But perhaps it takes some time to embed that intervention into the cluster, and perhaps we haven't allowed for that. Then this observation might be partly exposed to the control condition and not fully exposed to the intervention condition. So we get contamination with the control. Now there are solutions here. The solutions are to incorporate transition periods and also careful design, which we'll consider again in some future sessions. But again, another complexity that wouldn't arise with a parallel cluster design, because in a parallel cluster design, the control clusters would never switch over to the intervention condition. And then the fourth methodological complexity is what is referred to as time on treatment effects. So observations under the intervention condition, so these observations that we collect over here under the shaded cells, are a mixture of observations immediately after the rollout here on the diagonal, and also with observations that have been collected quite a long time after the rollout. So these observations down here have been collected sometime after that cluster has transitioned to the intervention condition. And this might have an impact if the intensity or the effect of the intervention either increases or decreases over time. Again, there are solutions. We can perhaps pre-specify that we're interested in the average effect, or otherwise pre-specify that we are interested in a treatment by time interaction. And again, we'll think about these things again in later sessions. So let's move on and look at a few case studies. So the examples that we're going to look at are going to illustrate the different types of stepped wedge trials. I'm going to introduce 3 examples. One will be of a cluster level intervention, one of a professional level intervention, and the other an individual level intervention. So again, these examples will illustrate the differences between cluster as in the unit of randomization and the unit of delivery of the intervention. But we're also going to illustrate the differences between cohort and cross-sectional sampling, routinely collected outcomes versus outcomes that are collected specifically for research, and then also look at large versus small numbers of cluster periods. So this is the first case study. This is called the I Promise study. It's a stepped wedge design, probably has a cohort design. So on the right-hand side, the left-hand side is a schematic of the study design. So there were 2 clinics in this study, Clinic 1 and Clinic 2. Under the first time period, T1, both clinics were observed under the control condition. At period 2, the first clinic transitioned to the intervention condition and then remains in the intervention condition. And the second clinic transitioned to the intervention condition at time period 3. So in this study, the I Promise study, the intervention was a patient-reported outcome measure, a PROM system, embedded within the electronic healthcare record. So it was a cluster-level intervention. The cluster was an outpatient cancer clinic. The design, there are 2 clusters, Clinic 1 and Clinic 2. There are 2 sequences, so Clinic 1 is allocated to sequence 1, Clinic 2 is allocated to sequence 2. And there are 3 periods, so 3 periods of data collection sampling. The study has a repeated measures sampling structure, it uses cohort sampling. It's possibly an open cohort, although it's unclear. So it's possible that participants were allowed to join the study after it had started. And the outcome was whether or not PROM report was available. So it's an implementation type outcome. The second case study is called the Care to Quit study. Now, in this study, the intervention was a complex care pathway. It included champions, best practice advice. Cluster was a cancer centre, and the design on the left-hand side had 3 sequences, so sequence 1, sequence 2, and sequence 3. Under sequence 1, there was a period of baseline collection, then intervention. In sequence 2, a baseline collection and the intervention condition started a little bit later. And in sequence 3, a longer baseline period and then the intervention condition kicked in a little bit later still. So 3 sequences, and there were 9 time periods, 6 time periods and 9 clusters. So 3 clusters allocated this time to each of the 3 sequences. So 3 clusters in sequence 1, 3 clusters in sequence 2, 3 clusters in sequence 3. Repeated measure sampling, again, it wasn't completely clear. It's probably cohort sampling. So it probably is the case that participants entered into the study at this point and then were repeatedly followed. But it's possible that it was cross-sectional sampling. It actually isn't clear. There was individual participant recruitment in this study, and the outcome was smoking cessation. This was collected specifically for the research purposes. And then the third study is called the Porsche study. Now this again is a stepped wedge trial, but this one's an example of a design with cross-sectional sampling. So the intervention here was a risk prediction algorithm targeted at the level of the individual. The cluster was a cancer centre. There were 17 sequences. Here are the 17 sequences. There were 17 clusters, so 1 cluster was allocated to each of the 17 sequences. Every cluster was observed under the control condition for a period of time and then switched over to the intervention condition. And this study design used cross-sectional sampling. Again, it wasn't immediately clear in the write-up of the study report. But this could be inferred. There was no direct participant recruitment, and the outcome was a major complication routinely recorded. Okay, so finally then, let's move on to think about how stepped wedge trials are being used in the current literature. So those are 3 examples of stepped wedge trials, but what do they look like more widely? Well, they typically, like all of the reviews that we have seen, don't include a huge number of clusters. So the average number of clusters in stepped wedge trials is just 17, interquartile range 8 to 38. The average cluster size is just 55, interquartile range 24 to 326, with a bit of variation there. Average number of clusters allocated to each step is 3, and the average number of periods is 5. Average study duration is about 16 months, and the average step duration is about 2 months. About 15 or 16% adopt a cross-sectional sampling structure, with the majority adopting a cohort or open cohort sampling structure. So then in summary, we've seen that the stepped wedge trial is becoming an increasingly common design choice. It has many characteristics in common with conventional cluster randomized trials, and especially those cluster trials that also include repeated measures, such as the cluster trial with the baseline period or the cluster randomized crossover design. However, it also brings about some significant methodological complexities, which we've very briefly outlined here. These include the fact that the stepped wedge design induces a confounder by design, that correlations are more complicated than the simple exchangeable correlation structure that we're used to thinking about in the parallel design, that these designs also become at risk of within cluster contamination because each cluster transitions from the control to the intervention condition. And finally, because the observations that we collect under the treatment condition are a mixture of those observed immediately after rollout of the intervention and those that have been collected sometime after the rollout of the intervention, this can induce time-varying treatment effects. So in the next sections, what we will do is start to understand how and when these additional complexities can offset the design's appeal. So, final thought that I will leave you with. So we've looked at the Porsche stepped wedge trial. You might ask, where is the Rolls-Royce of the stepped wedge trial? And I'm hoping that that's what you will be able to design after taking this course. So here are the methods references that I have cited over the slides and the 4 study references that were introduced through the case studies. So then up next in session 2, we are going to start to look at risk of bias and design justification.